Hi there, Katie with TutorPug. I'm gonna do a quick whirlwind trip through rational functions. Rational functions can be a lot of fun. Rational functions can be a big headache. So the first thing we need to know is, what is it? Okay, it's a ratio of two polynomials. If you don't know what a polynomial is, go back and watch my video on polynomials, and that will explain it all in the first couple minutes, so you'll know exactly what a polynomial is. Ratio means stack them on top of each other. Poof, now you have a rational function. This over here, 1 over x, is a very simple, very plain, stripped down, well-behaved rational function. 1 is considered a polynomial. X is considered a polynomial. I've stacked them on top of each other. Poof, a rational function. Here we have a ratio of two polynomials. They're getting a little bit messier, getting a little bit junkier. Doesn't matter. Rules still apply. You are a polynomial. Doesn't matter. Rules still apply. You are a rational function. Here, we have a polynomial on bottom. The top is not a polynomial because we have a variable under a radical, so sorry. Bottom down here, pause. Begin. Bottom one down here, m of p, got a polynomial on top, polynomial on bottom, so we have a rational function. When you're dealing with rational functions, these are the main things that you are interested in finding or will be responsible for finding. VA means vertical asymptotes. They are lines of an asymptote, A, S, Y, M, P, T, O, T, E, asymptote, is a line. It can be vertical, it can be horizontal, it can be slanted. It is a straight line that the rational function will approach but never touch or cross. So you will need to assess the vertical asymptotes. You will also need to assess the horizontal asymptotes. We also are concerned about the domain and the range, the x-intercept and the y-intercept. So I am going to I will do this top one, k of x, and I will do this bottom one, m of p, to run through what you need to find and how to find it. So first of all, let's start with k of x equals 1 over x. So the first thing I'm going to do is find the vertical asymptotes. Once I have found those, I will know the domain because they are linked directly to each other. To find the vertical asymptotes every single time, take the entire denominator of the rational function, set it equal to 0, solve for x. Whatever you get, those are the equation or equations of the vertical asymptotes. So if I take this denominator, which is just x, and I set it equal to 0, and I solve for x, thank you very much, it's done. That is my vertical asymptote. So this guy has a vertical asymptote at x equals 0, which happens to be the y-axis, which means this guy will not touch or cross the y-axis. It's like a big force field. Once I have found the vertical asymptote or asymptotes, I've got my domain. The domain is all real numbers except the value of the vertical asymptote or the values of the vertical asymptotes. So for this guy, my domain is going to be negative infinity up to 0, but I can't get to it or cross it or touch it, along with 0 to infinity. Once you find your asymptotes, you've got your domain. To find your horizontal asymptotes, if there are any, and this is one where it's a little bit, sometimes you have them, sometimes you don't. So this is something that a former student taught me, and it's Bobo Button Eats DC. This is one way, kind of a little mnemonic device, to figure out or remember how to know if you've got horizontal asymptotes or not. So BOBO, what that stands for is bigger on bottom, 0. Bottom, B-O-T-N, bigger on top, none. Eats DC. Exponents are the same, divide coefficients. So what do I mean by bigger on bottom, bigger on top? Exponents are the same. On a rational function, to figure out your horizontal asymptotes, you have to compare the degree, if you don't know what a degree is, go watch polynomials, the degree of the numerator to the degree of the denominator. And if I compare two things together, either this guy's bigger or this guy's bigger, or they're the same height, same size. So if I look at this, the degree of the numerator is 0. The degree of the denominator is 1. So in this example, bigger on bottom, yes, the degree of the bottom is 1. That is bigger than 0. Bigger on bottom, 0. So in this example, the degree of the bottom is bigger than the degree of the top. So his horizontal asymptote is y equals 0. Bigger on bottom, you have one horizontal asymptote and it is 0. Make sure that you always list your asymptotes as the equations of lines, because they are. And just a quick review, remember our mnemonic. So we've got Bobo Button eats DC, that's one mnemonic, one way to remember something. The other one, or another way to remember a different piece of information, is Hoivux. Hoivux says H is for horizontal, O is for 0, 0 slope, Y is for Y equals. What this means is that horizontal lines have a slope of 0, and their equation only contains Y and a number. So a horizontal asymptote is going to be Y equals a number. Vux, V is for vertical, U is for undefined, and X reminds me that Vux's vertical lines only have an X letter or variable in their equation. X equals a number. Hoivux. So horizontal asymptotes use Y, vertical asymptotes use X. Once I have found my horizontal asymptotes, I've got my range. My range is going to be all numbers except the horizontal asymptote. So in this example, for my range, I'm going to have, it's going to be the exact same as the domain, just going in the vertical direction, not the horizontal. So I'll have negative infinity to 0, skipping over that, along with 0 to infinity. Now I want to know my x-intercept or x-intercepts and my y-intercept. Well, sometimes we can sort of scratch our heads and go, will I have any based on this already predetermined information? If not, I know that my x-intercept will occur when I set the numerator equal to 0 and solve for x. Well, in this example, two things. First of all, there's no x in the numerator, so there's no way to solve. Second of all, we know that the y-axis and the x-axis are both acting as asymptotes, so this guy won't hit the x-axis or the y-axis. So I don't have any x or y intercepts on this guy. They just don't exist because we're not going to hit those. I already found that out with my asymptotes. So for the sake of argument, this is a very standard rational function, and he happens to look like that. Now let's take this particular one, pause, begin. Now let's take this particular one that I grabbed from over there, and let's figure out all of his key characteristics. So the first thing I want to know are my vertical asymptotes. That kind of drives the train. So I'm going to take my denominator, just the denominator, and I am going to set it equal to 0, and I'm going to solve for x, or in this case, p. Well, that's a perfect square binomial. It will factor like this. And if you don't like factoring, you can solve it with the square root property. I do a quick example of that in the polynomial video if you want to hunt through there. I prefer factoring if I can. It's just faster for me. So here I know that p is 9/4 and -9/4. I have to set each one of those equal to 0 and solve for the variable. So I just found my vertical asymptotes. In this case, it has 2, and it can. This has 2 vertical asymptotes, so it has 2 vertical lines that the function will not touch, not cross. It'll get closer, closer, but it won't touch or cross them. So the equations of my vertical asymptotes are p equals 9/4, p equals -9/4, and that means I automatically have my domain. The domain of this function is going to be all numbers except those 2 values. So the domain is going to be a little bit longer. I'm going to start at -infinity, but I have to hop over -9/4, not allowed to have it or touch it. Then I can have any number between -9/4 and +9/4, and then I can go to infinity. So if I think about a number line, there's -9/4 and there's +9/4. I really don't care about 0. And this, my vertical asymptotes, have told me that I am allowed to have any number, any number, any number, any number. No, don't touch it, hop over it. Any number, any number, any number, any number. Oh, nope, can't touch that one. Any number, any number, any number. So this is the mathematical interval notation way to describe the fact that I can have any number I want except those 2 particular values. Pause. Begin. To find the horizontal asymptotes, we're going to Bobo Botten eats DC it. Remember, bigger on bottom, 0. Bigger on top, none. You don't have one. Exponents are the same. Divide coefficients. So I have to compare the degree of the top to the degree of the bottom. In this example, the degree of the top, biggest exponent is 2. Degree of the bottom is 2. So we have eats DC. Exponents are the same. 2 is 2. Divide coefficients. If you don't know what a coefficient is, go back and watch the polynomial video. The coefficient, the leading coefficient in the top is +3. The leading coefficient in the bottom is 16. So my horizontal asymptote, hoivux, horizontal y, is going to be 3/16. I have one horizontal asymptote at the value 3/16. Once you find your horizontal asymptote, you've got your range. Now my range says I can have any number from bottom to top except that guy. Gotta hop over that. -infinity to 3/16 along with 3/16 to +infinity. Now let's find the y-intercept. On the y-intercept, I'm going to plug a 0 in for x or a 0 in for my independent or input variable. In this case, it happens to be p. So if I put a 0 in for this p, that term goes away. A 0 in for that p, that term goes away. a 0 in for that p. So what I'm left with is, if I put a 0 in for the p's, I'm going to be left with negative 36 over 81. So that is where we're going to hit, if x is 0, that's where we're going to hit the y-axis at that value. To find the x-intercept or intercepts, there could be more than one, I'm going to set the numerator equal to 0. And I hope you're thinking, well, Katie, you just told me in another video that anytime you want to find the x-intercepts, you plug a 0 in for y. Well, I am. I'm doing that in this example. Remember, on a rational function, on any function, the value of the entire denominator can't be 0. So I really don't care what you're doing. If I set that equal to 0, it's telling me what I'm not allowed to put in. So I don't care about that. But if I take the top part and set it equal to 0, that will tell me where I'm going to hit the x-axis, or in this case, the p-axis. So I have 36 minus 21p plus 3p squared equals 0. That's probably going to factor. I'm going to rewrite it so that my leading term is in the front, because it makes me slightly insane to try to factor it when the leading term isn't where he's supposed to be. So I want this to be in descending order. And I could factor out a 3. All of my terms can be divided by 3, which leaves me p squared minus 7p plus 12. And now if I want to factor, I am trying to see what two numbers multiply to give me 12, and then if I take those two numbers, same two numbers, and add them together, I get negative 7. Well, 12 is either 1 and 12. I can't combine those to get a negative 7. Or it's 2 and 6. Well, there's no way I can combine 2's and 6's to get a negative 7. How about a 3 and 4? Haha, I think we're onto something. And they're both going to be negative. Negative 3 times negative 4 gets my positive 12. Negative 3 plus negative 4 gets me my negative 7. So my two values are p equals positive 3, p equals positive 4. And that is where we're going to hit the p or x axis at over 3 up 0 and over 4 up 0. Pause. begin. So let's take this same theory and all the little pieces of information we know about rational functions now and work it backwards. Instead of being given a rational function and finding vertical asymptotes, domain, horizontal asymptotes, range, intercepts, etc., let's take some clues and construct a rational function that satisfies these. This is a little brain exercise. It takes some ingenuity to get through this, but it's using the same rules, just coming at it from the different direction. So I want us to find a rational function that has vertical asymptotes at x equals 3 and x equals -4, a horizontal asymptote at y equals 6, and an x-intercept at 0, 7/6. I can make these up all day. One thing to know is that there are multiple possible answers, multiple possible correct answers to these. There's typically one that might be the simplest or most obvious or quickest to find, but there will be infinite possible answers to these kinds of problems. What I do is I always start with my vertical asymptotes. The vertical asymptotes, again, really drive the train, so I'm going to start with that. And remember, vertical asymptotes happen when the denominator set equal to 0, solved for x, gives those numbers. This is actually the easiest part to find. I will name mine f of x, very original. It's a rational function, so it has to have a numerator and a denominator. And I know that I can pop those values with a changed sign into parentheses on the bottom, and poof, I have my vertical asymptotes. Because if I take a step forward and think backwards a little bit, if I test myself, if I was started here and I wanted to know the vertical asymptotes, I would set this equal to 0 and solve for x. Well, x minus 3 equals 0, x equals 3. And I would set this equal to 0 and solve for x. X plus 4 equals 0, x is -4. Done. So I have those conditions satisfied. Things might change a little bit. If you can hear that, that is not a screaming woman, that is a neighborhood peacock. I've got my vertical asymptote set. Okay, now it tells me it also has to have a horizontal asymptote at y equals 6. So I'm going to think back. Horizontal asymptotes follow the rule, Bobo button eats DC. If we have a horizontal asymptote that exists and is not 0, that means the degree of the numerator has to be the same as the degree of the denominator. Ha! So this guy, let's think about this. X squared, blah, blah, blah. If I factored or if I multiplied that out, I would get an x squared, and that would be the degree of this. So that means my numerator has to have an x squared term. Because exponents are the same, EATS, exponents are the same, divide coefficients. So this tells me that if I take this coefficient divided by this coefficient, if I multiplied that out, I need to get a positive 6. So I could start out and go, okay, there's 6. If I leave those as 1s, I've got a 6 over 1, which is a 6. Bobo Bottom eats DC, and make the coefficients be something that divides to 6. So this is where we can start getting different. I could put a 12 and a 2. 12 divided by 2 is 6. I could put a 36 in the top and a 6 in the bottom. So values, the rational functions can start looking different from each other because of the manipulations that I can do to still obtain that particular value. Okay, and the last one is it has to have an x-intercept of 0, 7/6. And back up. Start again. Lastly, it has to have a y-intercept of 0, 7/6. At the very beginning, I accidentally wrote x-intercept. It's supposed to be y-intercept because that's a y-intercept. So if I want to have a y-intercept of 0, 7/6, I need to remember back to what I had written on the board earlier about how do I find a y-intercept. Well, a y-intercept is when we plug a 0 in for x. So I have to figure out if I plug a 0 in for my x's and I want to get out 7/6, what do I need to do? How do I need to manipulate this? Because right now, if I plug a 0 in for x, I would get a 0 over -12. And that's not 7/6. So let's think here. If you want to go ahead and multiply this out to make it easier, you certainly can. This would be x squared plus x minus 12. If I multiply all that out, the denominator would turn into x squared plus x minus 12. So as it stands, if I plugged in a 0, I'd get 0 over -12, which is 0. That's bad. Okay, what can I do? So I need to add something or subtract something up here so that when that turns to 0, that turns to 0, and that turns to 0, what's left over divided gives me a 7/6. So here's what I can do. I know I've got something, some value over -12 has to equal 7/6. Whatever this is, divided by that, when all the x's turn into 0, has to be 7/6. So I could cross multiply, and that would give me 6 times question mark equals -84. 7 times 12, 84. So question mark is going to be -84/6. Pause. Begin. So question mark is going to be -84/6, which is -14. So if I come up here and I pop in a -14, I will have satisfied everything that needs to be satisfied. I'm just working this backwards. My vertical asymptotes would be +3, -4. Okay, check, check. My horizontal asymptote, Bobo Botten eats DC. Exponents are the same, divide coefficients. 6/1 is 6. And my y-intercept is going to be at 0, 7/6. Well, if this is 0 and those are zeros, I get -14 over -12, which becomes positive 7/6. I've done my job. These take some practice. It's making your brain think the other direction. It's uncomfortable at first. After a while, if you'll do 3 of them, they become a piece of cake. You just have to exercise that thinking muscle. It's like dribbling a basketball with your non-dominant hand or a soccer ball with your non-dominant foot. At first it feels weird and you fall down a few times, and then you get the hang of it. Math is practice. Go have some fun. Happy mathing.